Good morning, friends. It's Ben again. I'd like to apologize, first of all, that I did not get this video made last night. I got other things done, just did not manage to get this done. So sorry about that. In any case, this is a video for the Math Tech class where I'm going to try to run through essentially what you're doing for the assignment for today. Okay. This is the introduction to Google Colab Basics. As part of the assignment, there should be a link there where you can, excuse me, where you can open what's referred to as a Jupyter notebook in Google Colab that will be saved to, that will be accessible from your Google Drive. Hopefully you know how to deal with your Google Drive, okay? In any case, we're going to start in with that and just see what things that it's looking for you to do. Most of it has the instructions in the actual file itself, so you're probably able to read the instructions and follow along without the video. But just in case you need this, all right, I'm going to share screen, and I don't have the right thing open. Well, I'm going to not share screen because it brought up something. It brought up the Zoom thing in the screen that I was going to share. All right, so now we'll share screen. And what you'll see here is the hello class .ipynb. So it's a Python notebook or Jupyter notebook if you like. And when you get it, the first thing you're going to do is to make a copy. So if you've never done that before, you go up to File, and there should be something here that says Save a Copy in Drive. If you know how to do GitHub and stuff, great. I just don't, okay? So I'm going to save a copy in Drive. And it, tells me it's creating a copy, and then it bumps over here and it's got a copy. You can tell it's a copy because it says it's a copy, all right? So then you're gonna have to rename it. And so rename it, and I am going to go up here and I'm going to say mine is group 0, so it doesn't interfere with any of y'all's groups. And then I'll put Ben Marlin on it, and then I'll leave the hello class there. Okay, for y'all, you would do, both of the people in your group if you have 2 people in the group. Okay. All right, then you'll go over to this share tab here, right? Just one of you will go to the share tab, and then you, in this add people and groups, you will add the other person in your group if there's more than one person. And I'm going to just add one of the other teachers in the math department. Okay. Now notice that there are these options here and I sure hope this window is showing to y'all. There are these options that say viewer, commenter, and editor. You want to make sure it says editor so that both of you can make changes. And then you can send that, and then that person should have access to the file as well. All right. So we're going to run down through the file and look at what it says. And I don't want to read it to you, but I'm going to point out things that it says here. So notice that we have these 2 different kinds of what we call cells. This first one here that says traditionally the first program, blah, 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 is what's referred to as a text cell. It'll be in black and white, and it'll be text. So the second cell here is what's referred to as referred to as a code cell. That means it has executable code in it that tells it how to do things. So I'm gonna see if I can zoom in here a little bit. This is traditionally the first thing that people try out in a new programming language, is to tell it to print hello world. If you want to tell it to print something else, you totally can. but you hopefully noticed that I clicked on something that looks like a play button in order to get it to run, and then it printed out hello world. If you look at the code here, it's a function called print. And if you've taken a math class ever, you know, functions have to have parentheses after them. Oh, wow, it said built-in function, print. That's nice, okay. But the stuff that's inside of the parentheses is what's going to get printed. Now, notice that I have those single tick marks. You can always also use double quotation marks. Those will work as well. But whatever's between the tick marks gets printed. If I took off the tick marks, it would assume that I had created a variable that was named hello and a variable named world, and that I wanted those to be printed, and it would see that I had yet to say what those variables equaled. So it wouldn't know what to do. So in any case here, yeah, when you press the play button, it will execute it, but it's going to get really old having to go find that play button over and over again. So I would like y'all to do this as well. We've got the cursor in there. On my keyboard, because I'm using a Mac, it's Command Enter. If you're using a Windows machine, it's Control Enter. And so you hit Command Enter and it executes it, okay? If you want to take the thing it printed and make it go away, you can hit that, it goes away. So yeah, that's nothing really, really interesting, okay? Now, we're gonna look here at this next code block, and I'm just gonna talk about what's in it. So this piece here that says r equals 2 creates a variable named r and sets it equal to 2. If you're saying, man, that was really self-evident, why did Ben bother to say that? There are other programming languages where saying r equals 2 is not meant for assignments, that you have to do a special sequence or something, okay? But the equal sign is our assignment operator. You always put a variable name on the left, and then you put, I don't know whether this is mirroring for you or not. Yeah. You put a variable on the left equals, and then an expression on the right that can be evaluated. All right, so r equals 2, super easy to do, right? But then if I wanted to take 22 and divide it by 7, so I get 3.14 or something. So that's an approximation for pi, right? I would just, you know, put the operation in there. And here where I say quo equals 22 divide 7, so I put a little note out to the side, that's integer division. So when you divide 22 by 7 and ask for an integer to come back, then what it's going to turn out is to give you as a 3, right? Because 7 goes into 22 3 times, remainder 1. There is also this operation here that you use a percent sign to get the remainder. So those kind of operations are something that, you know, come up fairly often. So then this statement down here, C1 equals 2 times P1 times R, the asterisk means times. I don't know if that hadn't appeared yet. So, and what you need to notice is that we are allowed to use a variable name that we've already defined, but we can't use one that we haven't defined, right? So anyway, C1 and C2 are getting approximations for circumferences of 2 circles, because it's 2 pi r, but it's using 2 different approximations for pi, okay? Then this one here says val equals P2, that was the 3.14, asterisk, asterisk. So I don't like this, but the symbol for exponents in Python is a double asterisk. Other languages use a caret for it, but if you do that, it is defined to be a different operation, and it will give you something that's totally wrong. So this is saying to take P2 and put it to the power whatever R is. I think the R was 2, so it's going to square that, right? And now down here at the bottom, after doing all those operations, we're going to print stuff out. So see that my print, I say a variable name, and then, don't want to change it, and then a comma, okay? So if you've got a list of things that you want to print one after the other, then you've got to put a comma and list them. So the reason that I have that comma and stuff there is that I want there to be a space between the two answers, and that is not what happens by default. So I put C1 space C2. And then I say to print C2, and now this time I say tick mark \n tick mark. \n means start a new line, okay? And then finally I'll tell it to print C1 plus C2 just to show that you can do an operation in the middle of printing and that it'll, evaluate it beforehand. But then there's another neat trick down here where I've got this whole list of things that I want you to print. The quotient, the remainder, the value of R, and the value of, I think that was pi squared. And I say separator of tick mark space vertical bar space. So SEP, if you're in the nerd culture, you might say, is this somebody else's problem? And if you're not, then you have no chance to know that joke. It's from a series of books called The Hitchhiker's Guide to the Galaxy. But SEP equals is just saying, what will you separate these with, right? Now, I could go up and hit the play button, but instead I'm going to hit Command Enter, and it evaluates these. So remember what we were printing, the C1 space C2. So here's the value we got for 22/7, and here's, 22/7, and then times 2 and R. So I guess it would end up being about 4 pi. And here's the value we get when we do 3.14 times 2 and times R. And then on the next line, we go ahead and say that we want to print the C2, have a new line. So here's the C2, a new line, and then print the C1, okay? And notice that we don't have to have a new line at the end of every print statement, but if you do, then you'll get more space between and stuff. Okay, so C1 plus C2 on the next line, and that's about 25 point something. And then finally the quotient, the remainder, and the R value, so 3 and 1 and 2, and see how it puts the separation in there, okay? All right, so problem number 1. Now you're gonna have to do a little bit of math. So remember that if you got ax plus b equals c, that you can solve it by saying x equals c minus b over a. So down here, you're going to have to say x equals, now parentheses, what was it? C minus b over a. Hit enter. Okay. Nothing happened. Oh no. It must be broken. Computers suck, right? No, this stored the value into x. It's just that you didn't print it. Print x. Oops, I spelled print wrong. Hit enter, boom, it gives you your answer. All right, so that's what you're doing on problem number 1. I've done the problem for you. Can't get too much easier, right? So there's a little bit of explanation here about something we call numpy. Properly, we probably should say numpy, but then scipy. I like saying Skippy though, so maybe I'll say numpy and Skippy. But in this, we have a bunch of constants that are getting printed out. And if we just go ahead and hit enter here, notice that it puts a red line under the first statement. And if you put the cursor up there, it'll even tell you what the error is. And the error is that we've used NP all over the place and we haven't defined it. That's because I had commented out the NP part, okay? Now the error happens again at the first place that we have it. It says SC isn't defined. Well, that's because the place that SC is defined is up here. So what are Numpy and Skippy? They are packages that have a bunch of things defined in them. One of the things they have defined is a value for pi, a value for e, a value for infinity. That one's kind of questionable. It more defines a way of handling infinity than it does a value for it. SC of C. Why don't y'all Google and see what is C and see what you turn out. Man, that'll probably get us in trouble. But then G, that's another scientific thing that you should have encountered somewhere. You probably have not encountered mu sub naught, but Google that and see what it is, okay? And you ought to know what Avogadro's number is. Not particularly the value of it, but you ought to know what it's about. Google that and see what it's about. And then go back in here and modify these. I'm not going to do this part for you, okay? But modify these so that they say what the number is in addition to printing out the number, you know? So something like Avogadro's number is blah, okay? Not rough. So, but in any case, now that we have got all that stuff imported, it will now print each of those things in turn, okay? So C, G, mu naught, and Avogadro's number. There ought to be a standard like letter to stand for that. I don't know what it is though. Okay, so also in NumPy, there are a bunch of functions. And so in this next thing, I go ahead and show you, I put this comment out to the side to explain. The pound sign will comment anything that's after it, which means that the computer will ignore it. But I'm going to go ahead and import NumPy again. I don't have to do that because it's already been imported. But I'm going to go ahead and import it just in case somebody runs these in the reverse order or something. Okay. Then this next bit here says that I'm going to just import pi. And if you're saying, why did he do that? Why doesn't he just type np.pi over and over again? Because I got tired of typing it, so I just imported it, and now I can just say pi. So this print statement has us printing out the square root of 3. And this print statement has us calculating the sine of pi over 6. Please remember that all trig functions that are in Python always assumes you're using radians. If you've never used radians before and you have to use them, you should look it up and get that figured out, okay? It is a proportion on a circle between the length of an angle subtended and the radius. If I was speaking Greek on that, well, sorry, it's just something that you get in a trig class, okay? All right, then this down here has the cosine of pi over 4. Pi over 6 was 30 degrees, pi over 4 is 45 degrees. And it has this mysterious bit of arcane stuff before it. So let's actually evaluate it and see what it does, all right? So I'm going to just tell it to evaluate. Uh-oh, what did it not like? It did not like this one. Oh, no. Do you see what I did wrong? Okay. You will have to correct this in yours as well. And just go in and say np dot, because I didn't tell it was that np, that sign came from the NumPy package. Now when I hit enter, it'll do everything. Okay. All right. So if you see that this is the next to last line here, we get 0.07, or I'm sorry, 0.7071. If I took that piece out, so I'm going to just cut it and re-execute. Notice that it doesn't round off. So when we have that piece of code in there, it rounds it 4 places past the decimal. 4, and the F is for floating point. So if you put this little piece of code before a variable number name, it is going to round it 4 places past the decimal. You can figure out how to make it do 6 places or 3 places, right? All right. Anyway, though, cosine and tangent of pi. Whoa, what did it do? Okay. Tangent of pi over 3, that's the tangent of 60 degrees, which is about square root of 3. Notice it's not about square root of 3, it's exactly square root of 3. Notice that we have evaluated something here and something here that should both be square root of 3, and they are not the same number. But the disagreement is in these last 2 digits, right? So they agree 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 places past the decimal. When you calculate something 2 different ways, sometimes those 2 different ways have a little bit different way of rounding. So if any of you have done any programming in Python, we've got a course in that I don't remember if it's Rob or Shafiq teaches it. The last time I programmed in Python, admittedly over a decade ago, when you took 57 and divided it by 3, for some reason you got, instead of getting 19, you got 19 point, a bunch of zeros and then a 1. So anyway, calculations can give you a little bit different thing if they're set up different. But anyway, you didn't have to do anything in that. It was just experimenting around and seeing it. Now it's your turn. So I've forgotten what this has asked us to do, but oh, it's asking us to solve the quadratic formula, and it's asking us to go from scratch. So to get started here, you're going to have to be you're going to have to have clicked on this cell so that your cursor knows where it's at, and we need to add a add text. So let's see, cut cell, delete, nope. So why is it not, oh, there we go. Did y'all see that? It says plus code or plus text. I'm going to add a code of a cell of code, all right? And I need to solve this quadratic formula. So I'm going to say what the A is, 2. I might advise you to say 2.0 instead of 2, because sometimes you get quirky stuff where when you divide 2 integers, it suddenly decides that you want to get integer quotients. So it should not be a problem, but I've seen it come up occasionally. So I'm just dividing A and B and C. So my 2 solutions I want are x1 and x2. So I'm going to do x1 and you do x2. The way to modify it ought to be obvious. All right, oops, and I could make that a lot bigger so you could actually read it. So I forgot to put something in here at the beginning. I'm going to import numpy as np, okay? Now I could alternately have said this. I could have said from numpy import squirt. And squirt is, the name for square root. And if I did it that way instead, then when I write the formula, I can just write square root. I don't have to say np.square root. Okay. Do it whichever way you prefer to do. But let's see. The formula goes negative b plus square root of b squared minus 4 times a times c. and all that divided by 2 times a. Okay, so that's just the quadratic formula. And I am going to, after that, print x1. So I'm just going to make sure it works, and it got a solution of 1 out there. Okay, now the formula says negative b plus or minus the square root. So you need to figure out how to do x2. I'm not going to show you how to do that. And then also tell it to print the x2 maybe on a separate line or with a divider or something like that. Okay, so that was problem number 3. Problem number 4. So this one is talking about if we have a right triangle, and I don't have a picture for it here, sorry, but a right triangle with an angle of theta and a hypotenuse called C, then the other 2 legs, A and B, are going to be C cosine theta and C sine theta. Okay, so we're going to add a cell here again. Oops. So add code, import, nope, I'm going to say from numpy import, what do we need there? Sine and cosine. Okay. Notice that it gives us pop-up menu where it says, oh, numpy, you want numpy. Here's a bunch of things from numpy that you might want. So it tries to help you. It's not always helpful, but yeah. So we're going to have here C equals, what did it say? 10. And theta equals, notice you can use full words for your variable names, but you cannot have spaces in them. Okay. So theta equals pi. We already imported that, but I think I'm going to play it safe and go back up here and say import pi. But theta equals pi over 5. A is, what's A going to be? A was C times cosine of theta. And B was C times sine of theta. Now, remember, in a previous problem, we used A and B and C. It's okay to reuse variables. When you reuse them, it will just write the new version over the old version, and they'll just go away, right? But now, we're going to do a print statement. Okay, nope. I'm just going to hit enter here. You are going to do a print statement. So make it print out A and B and C. Maybe put some words in there. The sides of the triangle are blah, blah, blah. And maybe, what did it say? Round them 6 places past the decimal. Okay. That's stuff for you to figure out. You can totally do this. Okay. All right. So then the next bit here is going to look at something that we refer to as an array. Okay. An array is just a list of numbers. And so here we're going to start out with importing numpy as np. Numpy has a good way of handling arrays, and so we like to use numpy's arrays in there. So we're going to say n is 10. N is going to be the size of an array, and later we can go back and do it with a size 100, but right now we want to start small and just have like 10 of them. You could even do it with 5 as a start, you know. But your values are going to be np.a range of n. What the hell, right? So the np, of course, says it's going to be using the numpy package. And then it's got a function called a range that tells it how to make a certain kind of list of things, right? And so this certain kind of list, the a range, will have 0 as the smallest number, and then it will stop just before it gets to n. So if your n is 10, it will go 0 through 9. If your n was 5, it would go 0 through 4. Computers always start with 0 for things like this, and that seems confusing to most of us because we always want to start with 1. But let me tell you that the invention of the zero was like, is probably the hugest thing that ever happened in math. That's sounds goofy, but zeros are super important, and it actually makes a lot of sense after you program for a while. Okay. But anyway, though, we've got those values that are going to go 0 through 9. And then I'm just going to say print that out and put an extra line after it. And then after that, I've got this thing here that says values add 1. Now, this should be confusing if you have programmed in other languages, because in other languages, it would give you an error to do this. We have said plus equals, and that means add the following thing to it. And we got this single number. Which value should it add to? The 0, the 1, the 2, up to the 9? Which one? We have the nice advantage that because of the way Python works, it is able to think through things like, oh, Ben must want us to add 1 to all those numbers. It's referred to as casting. It handles these arrays in a nice way. But then it's going to print these out, print out the new results so that you can see that. And then I go ahead and I multiply them by 2, like that. And then I go through and divide out the 2, just kind of demonstrating how these sorts of things work. And the nice thing that we've got is that NumPy can take a square root of all those values at once, and it's fine with that. And that's a little bit weird, okay? Took me some getting used to do that, to be okay with that. I used to think that this was just a really bad thing to do, that it wouldn't work right, but man, it makes the programming easier. All right, so anyway, this np.squirt values will take the square root of each of the values. It doesn't store them anywhere, it just prints them. Okay, then we've got this bit here that should be super confusing. It says values 0:3, and it puts it in square brackets. So if you put square brackets after the name of an array, it knows that you want to talk about pieces of the array. If you say 0:3, then what that takes is that you want to go 0, 1, and 2. So the 0th entry, the first entry, the second entry, but not the third entry. It always leaves out that second one that you list. Okay, so anyway, we'll see the results on that here in a minute. Might have been more effective for me to just print that first. But then these last 2 things here do something kind of wacky. If you put 2 colons and then a number, it will jump through the array in kind of a weird way. Okay, so better to see it. Last thing we'll look at is this function called mean, which is just another word for average. All right, I'm going to evaluate this and make sure everything's working. So if you remember what we were doing, this first one was just the values 0 through 9. And then we added 1 to all of them. And then we took and multiplied everything by 2. And then we divided everything by 2. Yay, that was super exciting. And then here we have taken the square root of everything and printed the result. We did not store that anywhere. We just printed the result. Then this one here, remember that the numbers for positions go 0, 1, 2, but the things that are in those positions are 1, 2, and 3. Okay. Then, and so that was that 0:3 thing we did. And then this one here was when we said values : 2. So it printed entry 0, and then it jumped up 2 places and did entry 2, entry 4, entry 6, and entry 8. Okay. And then it would try to do entry 10, but we don't have entry 10. The last one is numbered entry 9. So when it gets to the end, it just says, okay, I'll stop. Another thing, and I think this is kind of a neat trick, is that if you say colon, -1, it will just print them backwards. So if you said colon, -2, it would go through them backwards, skipping over, 2 at a time. So you can play around with that a little bit and see what kinds of things it does. But then finally, if you take the average of the numbers 1 through 10, you get 5.5. And it's a built-in function. So there's a function called mean, maximum, minimum, max, and min. They don't spell out maximum and minimum. And lin for length. And there's several others there, and I don't even remember what they all are. But if you Google NumPy array functions, you'll get a list of them on Google. So, all right, so then this other thing we're going to do here is looking at a loop structure. So most of this we've talked about doing before, but there's some things that are new. So when you're at the beginning of something, everything's new. So and because we're in a 3-week class, we can't just say, here's one new thing, go sit with that for 2 days. We have to do it all at once. Sorry. But I'm going to go ahead and import NumPy like I did before. But now I'm going to import something new. NumPy.random is a package inside of NumPy that has a lot of things about getting random numbers and stuff. So, all right, we're going to start out by saying the size of our array is 10, and we're going to want a bunch of numbers whose average is 50 and whose standard deviation is 10. So the other day, when we did stuff in Excel, I used an Excel function to generate these and had much the same kind of numbers to deal with. Okay, so this is just the NumPy version of that, the Python stuff. So we're going to make an array called X. It is going to use the NumPy random package, and it's going to make things come from a normal distribution with that average of 50, standard deviation of 10. And then I go ahead and when I tell it that 10, it says, oh, he wants 10 random numbers, and it knows to make an array. If you didn't put that comma n at the end, then it would just give you one number back. But because I put the comma n is 10, it makes an array just like the array values that we were talking about before. It's just this time it chooses a bunch of random numbers for us. So then for some things to print out, I went ahead and demonstrated the NumPy function that rounds things to and in particular the 3 decimal places, but you can do it to whatever number of decimals you want. And then this function here that will sort stuff. Remember when I kept forgetting to sort that column of numbers? Well, this then will sort the column of numbers. So anyway, then I have it go ahead and print stuff. I'm going to go ahead and run that code so that we can go down here and look. So here's the numbers that we got from it, and you can see they're nice and messy. And then here is what happens if you tell it to round it 3 places past the decimal. And then here is what happens when you tell it to sort. So bearing in mind, I didn't sort the rounded ones. Maybe it would have made more sense to sort the rounded ones. If you're looking at this and saying, hey, why doesn't he use that %0.4f crazy thing that I used before? Well, it turns out that you get an error message if you try to apply that to an array. You can only apply that to a single number at a time. I did not know that. So anyway, that's showing you the results that we had for those first 3 things of randomizing some numbers, doing the rounding, doing the sorting, right? Now let's go back up and see what else we're going to do. So if you've had a stat class, you know that very often you have to take the average and the standard deviation. And so here I'm going to store as a single number the mean, which should be pretty close to 50. and the standard deviation, which should be pretty close to 10. And then I'm going to take and make a new array called Z. And with this Z, I'm going to start out with the array X, and from every member of it, subtract the average, and then to every member of it, divide by the standard deviation. And this is what we refer to as the Z-scores for some numbers, okay? And then I went ahead and used a for loop here, and this is your first exposure to loop structures, okay? So breaking it down, for tells it it's gonna do a loop, I in NP range parentheses n, okay? So that NP a range of n, you know what that does. That generates the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? So this language of I in that NP range means that it's going to take those numbers 0 through 9, and I is going to start with 0 and do everything in the loop, and then it's going to come back and get 1 and do everything in the loop, and so forth until it gets to the end. This colon is necessary so that Python knows that you're about to start the interior of a loop. If you hit return after that colon, it will automatically indent the next piece down here. And the way Python knows that you're done with the stuff that's in the loop is that you quit indenting. If you continue indenting, it will leave it inside the loop. And that can get very confusing and mess some things up. So anyway, but I've told it here to go through and print these. And as you can see, it just went through the original set of numbers. And oh, I told it to print 4 digits past the decimal on both of those, just so the printing would look relatively nice. Okay. So it went through the loop and said, okay, for the 0th entry, here's X, here's Z. For the 1th entry, here's X and Z. For 2, so on and so on and so on, okay? Now, that's not very interesting, but that is the original purpose for computers, was to do things that weren't interesting, but were necessary. Because when people did these calculations, you ever watch the movie Hidden Figures? It's a really decent movie. They made math mistakes in it, but the emotional impact, the meaning for that movie, it was just spectacular. In any case, though, some of the main characters worked as calculators. They sat down and just did math, just did it by hand. And when humans do math by hand, they can do more intuitive things maybe and jump to the end or whatever, but sometimes you make mistakes because your brain gets bored and plays tricks with the numbers or something. So computers only make mistakes if we program them wrong. So and they don't get bored. But anyway, I'm going to cut that out, and we're going to go ahead and look at the problem number 4 here. So the code that we've got, if we go ahead and hit enter, takes and generates a bunch of random numbers, okay? So n equals 10, so it's going to generate 10 of them. And then the dice, I put in here 6 plus 1. So you remember that thing where it only goes up to 1 less than the number you give it? So I put 6 plus 1 so that I would remember that, okay? So then when I say npr rand int, random integer, 1 is the smallest one, and then dice is 1 more than the number of sides. So since the dice we stored 7, this will give me random numbers from 1 through 6, okay? And this last part, the n, says I'm going to make an array of 10 of them. And then we have a function built into arrays that just automatically does the sum. but I want to show you how the guts of that works, because we don't have something built in to do the product. I'm sure if you Google, you'll find some trick to do it, but that's not really the point here, okay? So I started out with sum being 0. When you start out with product, which is what you're supposed to do, you're going to have to start it with 1, okay? And then we have our loop here that says for d in x. So it's going to pull out and use the number d to deal with it as, and it's just going to pull out the first number, the second number, the third number, and so forth, okay? And this one says to take the sum and add the current value of d to it. So it just steps through, starts with 0, and just adds all those d's in there. And then at the end, we tell it to print this, okay? And that's what we get. And if you check, that will be correct. Now, for you, you're doing product. If you start with product being equal to 0 every time, and you start multiplying, every result will be 0. So you want to start with product equals 1. I'm not going to type that, but you're going to, okay? So product equals 1, and you're going to go through the loop here, and you're going to say product, not plus equals, but times equals, okay? And then at the end, you're going to modify this in order to print out the numbers that you've got and what their product is, okay? Should be pretty straightforward. So anyway, that's your problem 4. Your problem 5 is building on that. So that function called average really takes the sum that you would get from a bunch of numbers, and it divides it by n. We refer to that with an x bar. So there's something called the geometric mean, which is similar, but it has to do with multiplying and then putting to a power. So our code here, when we execute it, generates a bunch of numbers, and then it figures out their average. And the way that it figures out the average is to calculate the sum, just like we did before. And then in the variable called average, it just says sum divided by n. Now, for you, you're going to figure out the product. And now at the end, instead of taking the product and saying, instead of saying product divided by n, you are instead going to say product to the power, parentheses, 1 over n, okay? And then the print statement you'll have to adjust as well, okay? So you figuring out some of this, I'm going to leave that to you. It's really 5 problems for you to work out. I've done a fair bit of it for you, but there's still some for you to figure out. So I will be there in class. I'm not feeling 100%, so I'll be there as long as I can. I might have to take a nap or something. So, all right. See you all in class. Take care.